All right, so here is the review sheet, the correct review sheet for solving quadratics. I'm going to go through them real quickly with you. So we started off by solving quadratics and finding the roots by factoring. And this is just kind of like a classic, except I just messed it up. Isn't it 5 and 1? What am I thinking? It's easy to get confused sometimes, but yeah, x minus 5, x minus 1 equals 0, so x is 5 and x is 1, right? When we've got something like this, the temptation sometimes is to divide everything by x. You can never, ever, ever divide by a variable, because what happens is you could essentially be dividing by 0, like in this case one of the answers is 0, so you're not allowed to ever divide by a variable. And then here, when we factor this one, it's going to be 5x minus 2, x plus 3. And I'm fine if you don't even show that extra work and you just solve that in your head and get 2/5 and negative 3. So factoring should be super easy for you. Quadratic form, this is when, it looked quadratic-ish, or so we say. It's technically not a quadratic, that's actually a 4th degree equation, but I can factor it like a quadratic, and then I can factor it again. And then when I'm all said and done, I get the answers of negative 2, 2, negative 1, and 1. All 4 answers. Here when we factor out a square root. Square root always goes in that first term, minus 9 minus 1. And then these, when we solve them, you have to be a little bit careful. You're going to add 9 to both sides. And so then if I square both sides, x is 81. Add 1 to both sides, x is 1. This one I crossed off in 2020, but I'm going to show it. X to the negative 1, x to the negative 1 equals 0. And then here it's plus 3 and minus 2. And remember that x to the negative 1 is really 1 over x here. 1 over x would equal 2, so the x here solves to negative 1/3, or the x here solves to 1/2. When we do completing the square, that's when we make sure the leading coefficient is 1, leave a blank on both sides. Half the middle number squared here is 4, so you're going to add 4 to both sides. Factor the left-hand side, y plus 2 squared is equal to 15, square root, so y plus 2 is plus or minus root 15, and if I finally, move that to the other side, negative 2 plus or minus root 15. It gets a little harder when there's an odd number in the middle, so here it's 1, half of 1 is 1/2, 1/2 squared adds 1/4 to both sides. And then this is equal to 6 1/4, but I like to write it as an improper fraction, 23/4. So x plus 1/2 is plus or minus the square root of 23. Square root of 4, of course, is 2. So now you can subtract 1/2 from both sides, and since they both have a denominator of 2, all over 2. The hardest one here would have a leading coefficient of 2. So if I divide everything by 2, and then this is equal to 1/2. Half the middle term squared, so half of 3/2, and it doesn't matter even that it's negative, is negative 3/4, and when I square that is 9/16 that gets added to both sides. So again, if I factor the left-hand side, I'm going to get x minus 3/4 squared equals, that's really 8/16, 8/16 and 9/16 is 17/16. X minus 3/4 is, it's a minus there, plus or minus root 17, the square root of 16, of course, is 4. So the final answer, 3 plus or minus root 17 all over 4. When we can't factor, another thing we can do is use the quadratic formula. So the a is the number in front of the x squared, the b is the number in front of the x, and this one happens to have a c of 0. It's opposite of b, plus or minus b squared minus 4ac all over 2a, 14. This one is nice because when I simplify it, I get a perfect square. The square root of 21, of course, is 21. So I have 21 plus 21 over 14. And that turns out to be 3. And then 21 minus 21 over 14, 0 in the numerator, turns out to be 0. You don't have to write out that a equals, b equals, c equals. It's fine to just jump right into it. I like to show this work, though, the 4ac all over 2a. Nice thing about that is it's the square root of 0. And of course, the square root of 0 is just 0, so here we get 3/2. It's technically a double root, but it's fine to just say that x is 3/2. And then this one here, I have to move the 4 to the other side before I assign my a, b, and c. So it's opposite of b, plus or minus b squared minus 4ac all over 2a. So that turns out to be negative 12. Of course, that can simplify to 2i root 3 over 2. And then those 2's can all like reduce here. So it'd be negative 1 plus or minus I root 3. Yeah, that's it. The discriminant is under the square root, right? So b squared minus 4ac. And you write the answer before you take the square root. So b squared is 1 minus 4ac. That turns out to be negative 23. A negative means 2 imaginary roots. B squared here is 36 minus 4ac. That turns out to be 0. So this is one real root, also a double root. And then here, b squared minus 4ac turns out to be a positive, so that's 2 real roots. When we give you the roots, we go backwards to FOIL to the answers. I would take this factor as 2x minus 1. The big thing that people forget here is that it's an equation. So don't forget the equal sign in the equation. So that actually equals 0. X minus root 7, x plus root 7. When we FOIL that out, first outers and inners are going to cancel out. You just get x squared minus 7 equals 0. Same thing here, x minus 3i, x plus 3i equals 0. X squared, outers and inners cancel out. You get minus 9i squared, which is the same thing as plus 9 equals 0. Pick it up at the back of the worksheet. So now we're graphing, right? So x minus 3 quantity squared, we know that that goes right 3. So this is the vertex of 3 comma 0. And then don't forget that the axis of symmetry, vertical line through the vertex, is actually x equals 3. Here, this one's going to move left 4, down 0, and it's going to be upside down and kind of wide. X equals negative 4, right? And then here, this one goes right 1, down 3. So right 1, down 3, and the negative 2 is going to make it kind of tighter there. Axis of symmetry, of course, x equals 1. That was all really the first half of the chapter. Now we're going to change it from vertex form to standard form. And essentially that's just foiling that out. Right? There's your standard form. And then originally it was given to you in vertex, aka graphing form. If you're a good foiler, you could just foil in your head, right? And then clean it up. X squared minus 2x plus 7. Here I changed it to f of x notation and then added that 2. So I usually keep that 2 outside there at first, and then it's going to get distributed. So 2x squared minus 16x, and then it's going to be 32 plus 6, or just 38. When it's in standard form, to write it in graphing form, this is what we learned about changing the form. You kind of isolate the first 2 terms and leave a blank on both sides. Half the middle term squared here is 1, but the y likes to be alone, so that gets scooched over. And then when I clean that up, it's just x minus 1 squared. And actually, I'm looking at that. I probably could have just written that right off the bat as x minus 1 squared. That's okay. Vertex is 1, 0. Axis of symmetry, x equals 1. Here we're going to factor the leading coefficient out. Remember, we're only factoring it out of the first 2 terms, even though the 10 is even. Half the middle term squared there is 100, but when I balance it out, notice that I add a 200 to the other side. That's because it was inside those parentheses. So this turns out to be 2x minus 10 squared minus 190. And of course, we're not going to, graph something like that, x equals 10. Here, I'm just going to factor out the negative from the first 2 terms. Negative, that changes it to x squared plus 10x. Leave the blank on both sides. Half the middle term squared, of course, is 25. But when I balance it out, I'm going to subtract 25. And then add 25 to both sides. So here I get negative x plus 5 squared plus 35. So the vertex here is negative 5, 35. X equals negative 5. And that graph would be upside down. Now we're at the story problems. Find 2 numbers whose difference is 8. The variables for that is x and x plus 8. And you can think about that a little bit if you need to. So it's x squared plus 8x, and now I'm just going to, again, change the form. Add 16 to both sides, but then move that 16 over. This gets factored. x plus 4 squared minus 16. So my vertex is negative 4, negative 16, x and y. So the x, remember, is the first number. So the first number is negative 4, and then the second number is negative 4 plus 8, or 4. So that's my answer there. Here, the perimeter, the area, so the perimeter is 48. If these two sides, let's say, are x, doesn't matter which one's the length and which one's the width, the other two are going to be 24 minus x. Some people get confused why that is. It's 48 minus 2x divided by 2 is how we got the 24 minus x. So now the equation is x times 24 minus x, so negative x squared plus 24x. Now I've got to factor out that negative, half the middle term squared to both sides, so that's what, 144? But it was really a negative 144, right, because of that negative sign, so I add 144 to both sides. So now I have the negative of x minus 12 squared plus 144. So 12 comma 144. And again, x was the length or the width, it doesn't matter, and then 24 times minus 12 is 12. So it's basically a 12 by 12 square. Last thing is another problem here, but now the width, it says it's, a house is being used as one side of the pen. It doesn't matter which side you cross off, but basically now you're not going to divide that by 2. And I purposely chose the same numbers so you could kind of see the difference between those two problems. Again, I'm going to factor out the negative 2, changing it to x squared minus 24x, leaving the blank. Half the middle term squared is 144, which is really a negative 288. So when I add it over here, 288. So I get negative 2x minus 12 squared plus 288. So my vertex, 12, 288. So the rectangle there is actually a 12 by 24. And then for the people money question, sometimes people get confused on the variables. This is the number of $3 increases. So they usually sell 40 pairs of jeans at $30 each, right? Each time you increase the price by 3, you sell 2 fewer pairs of jeans. So this has to get kind of like foiled all together. I probably didn't write, let's see, like 1200, 120x minus 60x minus 6x squared. So if I clean that up, I have what? Negative 6x squared plus 60x. Yeah, plus 1200. So I've got to factor out the negative 6x squared minus 10x plus 1200. Half the middle term squared is 25, but that's really negative 150 that gets added. So when I factor it, negative 6 x minus 5 squared plus 1350. So the vertex is 5 comma 1350. And remember, 5 was the number of $3 increases. So if I have 5 $3 increases, I'm increasing by $15. The original price was $30, so I'm going to add that in, and then it would be 45. Perfect. And then this one I'm going to solve by hand. You could solve it on the calculator, and that would just reinforce the answers. We have, this is our equation. H is height, T is time. When does the ball hit the ground? Whenever it hits the ground, that's when the height is 0. So I'm just going to divide everything here because it's an equation by negative 16. T squared minus 3t, so I get here t minus 3. So it's going to hit the ground at 0 when it starts, and then 3 seconds. And if you graph that, you would see the same thing. How high is the ball after 1.3 seconds? It wants me basically to evaluate that function at a t of 1.3. So in other words, plug in 1.3 for t. And of course, you could do that on your calculator, 35.36 feet or whatever it is. What time does the ball reach the height? Now you're changing the original equation to vertex form. So negative 16t squared, I'm just going to make it an ht squared plus 48t. So I'm going to factor out that negative 16. That changes it to minus 3t. Half the middle term squared. Half of 3 is 3/2. Squared is 9/4. But when I go to multiply that and add it to the other side, it's actually negative 36, which just gets added over here. So I have h equals negative 16, t minus 3/2 squared plus 36. So that means my vertex is 3/2 comma 36. So what time does the ball reach the height is 3/2 or 1.5 seconds. And what is the height is the 36 feet. So there you have it. There's the test review.